Signals are arguably the most important part of any rail network. Without them, the safety of the railway would be compromised, as various trains traverse the strips of iron that crisscross their way here, there and everywhere. Signals in OpenTTD are therefore just as important, keeping your trains from crashing into one another and ruining your perfect network. But how exactly do signals work in OpenTTD, and in particular in the JGR patch? Let's take an in-depth look. Hello everyone, I'm M4J and welcome back to the OpenTTD tutorial series. Now, unlike previous episodes in this series, this video is 100% scripted. I'm literally reading from the script right now. I mean, sure, I'll probably go off script at some point, as I always inevitably do, but there are good reasons why this one in particular is scripted. Firstly, it helps stop me from waffling on and taking up your valuable time. And secondly, it means I have a chance to actually make sure I've covered everything before publishing the video. I'm saying that all too aware that I'll most likely definitely miss something out, only to be told so in the comments. But hey ho. So today we're back looking at signals, but this time I'm going to be talking in more detail about the types of signals in OpenTTD, as well as how to place them on your railways, and even how to switch between signals both before and after placing them on the rails. Now, as usual, this tutorial is mainly aimed at those looking to build realistic networks, those wanting to create something similar to the M4J network, so not everything I say may be useful to you. Also, I will only be focusing on the basic types and functionalities of signals. Shunt signals will be the subject of their own video sometime down the line, pun fully intended, and signal programming has already been covered in this series. Alright, with all that said and done, let's get started. Let's start off by talking about the types of signals. This guide will only show you the signals available when using the JGR multi-aspect signal new GRF and the realistic braking feature in the JGR patch of OpenTTD, as that's how I've configured my game. When using the JGR multi-aspect signal new GRF combined with realistic braking in OpenTTD, there are two main types of signal, these being block signals and path signals. There are also semaphore signals and color aspect signals, but these function the same, so I'll only focus on color aspect for this video. Blocks are sections of track between signals, with block signals detecting the occupancy of the following block. If the line ahead is clear, the signal will show green, or off. If the line is occupied, the signal will show red, or on. The multi-aspect signals can also show either a yellow or double yellow depending on how far ahead a red signal is, with a single yellow meaning the next signal is red, and a double yellow meaning the signal to ahead is red. Block signals are constantly checking the block ahead to determine which color aspect to display. Path signals work slightly differently, as these signals detect the route, or path, of the oncoming train before determining whether to show a red or green aspect. Even if another train is occupying a junction block as the train approaches, if the path of the train is clear, the signal will switch to green. By default, path signals always show red until a train approaches, so don't worry, your train will still find its way even if it looks like it won't. Path signals also come in two varieties, these being one-way and two-way. We'll cover these in more detail later on in the tutorial. To place signals in OpenTTD, select them from the Signal Selection panel, then click on the track to build. It's important to ensure that the aspects face the approaching train, as block signals and one-way path signals will not allow trains to pass the signal in the opposite direction. If your signal is facing the wrong way, click the signal again to flip it around the right way. If you wish to remove a signal, click the Remove tool while the Signal Selection panel is open, then click the signal to remove it. If you've placed the wrong signal type, instead of removing the signal and replacing it, you can instead use the Signal Convert tool to swap to the right signal type. Simply click on the signal type you wish to change your signal to, then click on the signal to swap it out. Unlike removing and replacing, this can be done at no additional cost, saving you precious revenue. Alternatively, you can hold the control key on PC and click on the signal. This usually cycles the signal through all available types, but for some reason at the time of recording, it only cycles between the two types of path signals. If you're looking to signal large sections of track at the same time in OpenTTD, you can use the control key on your PC. First place the initial signal for that piece of track. Then, hold the control key, click and hold on the signal, then drag in the direction you want the line to be signalled in. Before doing this, it's important to make sure the first signal is facing the right way, and is the correct type for the entire line. My advice is to start at a junction, then head backwards up the line. Then, once the line is signalled, you can swap out the signal controlling the junction entry with a path signal. To select the distance between signals, use the signal dragging distance section of the signal selection panel. Remember that the number displays the numbered tile that the next signal will be placed on, so 13 will actually only contain a gap of 12 tiles between signals. Placing signals this way also works for tunnels and bridges in the latest version of JGR. It's also important to note that the signal dragging is interrupted by both stations and junctions, so it's advised to build your stations after the route is signalled and keep junctions to a minimum if you want a continuous line of signals. Finally, let's talk about how to signal junctions themselves. In OpenTTD, it's crucial to know which signal type to use at each section of a junction. Path signals should always be used at the entrance to junctions, as this way multiple trains can occupy the same block across the junction, so long as no paths intersect one another, of course. On junctions where slow lines and fast lines connect, this means all 4 lines can still operate so long as the trains continue along the same tracks, greatly improving line efficiency. It's also important to know which kind of path signal to use at junctions. If your lines are unidirectional, where trains run in a single direction, you need to use one-way path signals to prevent trains using the wrong track to exit the junction. If your lines are bidirectional, where trains can run in both directions, then two-way path signals are required. Two-way path signals can only stop trains travelling towards the aspect side of the signal, so make sure your signals are facing the correct way. It's also important to leave a gap between the junction and the length of your longest train before placing the first exit block signal, so as to not block the junction if a train needs to stop for any reason. And that's everything you need to know about the basics of signalling in OpenTTD. If you're looking for a more advanced tutorial on how to implement route restrictions, speed limits, and other programmable features using signals, check out my tutorial on that on the screen now. Also, if you have any other questions about signalling in OpenTTD, feel free to ask me in the comments below, or join my Discord via the link in the description and ask in the M4J network chat. For now though, thanks for watching. I hope you found this tutorial helpful, and if you did, why not hit the like button and share this video around to help other OpenTTD players. Besides that, if you haven't already subscribed to the channel, be sure to do so for more tutorials just like this one. And if you have already subscribed, thanks for your continued support. Enjoy the rest of your evening. I've been M4J, and until next time, I will see you soon.